Assalamualaikum and hello. We are going to start the first chapter for SK015, chapter 1, matter. There are 3 subtopics in this chapter. I'm going to focus for the first subtopic, atoms and molecules. Let's go with the learning outcomes for this subtopic, where there are 4 of them. We are going to focus in this video about the introduction to atoms and molecules, including with how to write the isotope notation. First thing first, you have to know what is matter. Matter is anything that occupies space and has mass. These two are keywords which are very important for you to identify anything which is matter. For example, everything in this world, such as air, water, animals, trees, atoms, or anything, they are all matter. So matter in more simplest form may consist of atoms, molecules, or ions. And there are 3 states of matter. For example, you can see here the first one is solid, second is liquid, and the last one is gas. So if I tell you before, we have our own earth itself, so we can understand that everything in this earth can be matter if that anything has mass and occupies the space in this earth. Next one, for example, I have this chair. So in this composition of making this chair, we have certain molecules that are made up from a simple small atom. So from this small atom, we can make it more detailed as the structure of the atom itself. And from the structure of atom itself, you can zoom in the center of it. There is a nucleus which containing proton and neutron, including with the electron surrounds the nucleus. So I hope you are clear with the introduction of what is matter. Now let's continue with what is atom. An atom is the smallest unit of a chemical element or compound, and it is made up of 3 subatomic particles. I hope all of you can understand the 3 subatomic particles are proton, neutron, and the last one, electron. These 3 are 3 subatomic particles of an atom. For proton and neutrons, both of these are packed in the small nucleus. However, for electron, it is positioned and move rapidly around the nucleus of an atom. As you see from here, there is the nucleus in the middle, and inside this nucleus, there are neutron and proton. And outside the nucleus, around it, there is electron. In a simpler way, we also can use the Bohr atomic model to show the 3 basic subatomic particles of an atom. As you see from here, this is the general structure that I've already introduced from the previous slide, but you can also choose to draw in this form as you've learned during SPM syllabus. So you have to understand the charge for the proton is positive. However, the charge for electron is negative. So they are in opposite sign. For the neutrons, they have neutral charge, which means that there is 0 net charge. And since the opposite charges attract, proton and electrons can attract to each other. This is the specific values for subatomic particles, specifically for 3 of them, electron, proton, and neutron. And the mass of them is very, very small. That's why we use the unit atomic mass unit, AMU, where 1 AMU is equivalent to 1.67 times 10 to the power of negative 27 kilogram. And you can also see the value for the charge in coulomb or in specific units. As I mentioned before, electron is in negative sign, so negative 1. Proton is in positive sign, positive 1, and neutron has 0 net charge. The value will be 0. Now you've learned about subatomic particles. We are going to focus about the proton number. So proton number, the symbol is Z. We can also call it as atomic number. Proton number is a number of protons in the atomic nucleus. As we know, it is positioned in the middle of an atom. Next one, I want to introduce to you nucleon number. The symbol is A, capital A. Same goes for proton, capital Z. So the other name for nucleon number is mass number. It is the number of protons and neutrons in atomic nucleus. So there is a summation for protons and neutrons. So these two are very important for you to use in order to write the isotope notation. We can represent an atom by using isotope notation or atomic symbol, where I have this symbol. X is the element symbol based on the periodic table. Capital A here at the top left is the nucleon number for that element, and capital Z here is the proton number of that element. I put extra term here for the charge of element because sometimes the element that we have to write got a charge. And here a bit summary how you want to calculate the number of electrons based on their character, whether the atom has 0 net charge, or the second case is charged atom with positive sign, and the next case charged atom with negative signs. So both of these are for the ions. So let's go to this example. This is isotope notation for mercury, where I have the nucleon number of mercury, capital A, is 202. And the next one, I have proton number for mercury, which is 80. So the symbol for the proton number is capital Z. So from here, I can calculate my number of neutrons, where I minus the value 202 minus 80. I will have 122 for my neutron. And the next after that, I can see that there is no charge here for this element symbol. So you can say that it is 0 net charge. And then how to continue if the question asks you to calculate the total charge of an atom? You know that mercury has no charge here, but how can you prove that? You are going to calculate the total charge of this atom, where calculate all the proton numbers and electron numbers times with the sign of the charge. You will have 0 as your total charge. Thus, you can understand the number of neutrons is 122, proton is 80, and electron is 80. So for the isotope notation of neutral atom, the proton number and electron number should be same, as you see from this example. Let's continue with the second example. I have magnesium, but with charge here 2+. So what we're going to do, we are going to determine the nucleon number for magnesium is 24 and the proton number is 12. So I will calculate the number of neutrons, which is 24 minus 12, I got 12. And due to the charge is 2+ here, we can understand this is a positively charged particles. So that's why it is indicated here. And next, I'm going to prove whether I got the total charge the same value as positive 2 or not. I'm going to calculate the total charge of this ion, where finally the value is the same. But when you calculate, you are going to put the positive sign at the front of the number. But in isotope notation, positive sign should be behind the number. So please be careful. There is a tricky way to write isotope notation for element that has a charge. Thus, you can determine the number of neutron is 12, the number of proton is 12 as well, and the number of electron is 10. Why? This is because we have the number of proton minus 2. Positive 2 here indicated that magnesium donated 2 electrons. That's why we have to minus 2. That's why the number of electrons less 2 from the proton. So in this case, for ion, you should understand that the number of proton should be not the same as number of electron. Let's go to the last example for Cl minus. Usually we write it down as Cl minus because it's much more easier, but in this case I want to show you, but make sure in isotope notation negative sign should be behind the number. So let's go to the nucleon number, which is 36, and proton number, which is 17. I'm going to calculate the number of neutrons. The final one I got 19. And this is negatively charged particles. That's why we have -1 as the total charge on that ion. By proving from this calculation, you got the same as here. And the final one, you can understand that the number of neutrons is 19, the proton number is 17, and the electron, due to the negatively charged particle, negative sign means that it accepts electrons. So one electron is being added. So from 17, it will add up 1. So the electron should be 18. So same goes for the negatively charged particles. The number of proton is not equal with the number of electrons. I have one example where usually element is represented by using the nucleon number as this one, sodium-23. So how you want to determine when you got this kind of question? First thing first, this number 23 is referring to the nucleon number. So you have that one as your first information. The next one, you are going to determine the subatomic particles. There are 3 of them, number of proton, neutrons, and electrons. So the number of proton, how I got 11. This is where you are going to use table of relative atomic mass. And here, from the table, I got 11 as my number of proton. So can I determine the number of neutron? Yes, I can minus. And the value for the number of neutrons is 12. And due to this sodium as a neutral atom, there is no charge. So that's why the number of electrons same with the number of proton. So from this video, I hope all of you understand what is matter, what is atom, and from there you can understand about 3 subatomic particles and how to write isotope notation based on subatomic particles and nucleon number. That's all for this one. Thank you.